Okay, algebra, we are nearing the end of the factoring chapter, and the last thing we're going to get good at is factoring completely. And so to factor completely, you just have to put all your skills to use at the same time. Okay, so things that we know. We know how to take out a common factor. Sometimes this is called a GCF, the greatest common factor. If it starts with a negative, you take out the negative. I also noticed that the number that they can both be divided by is 3. And how many x's can I take out? 1x. Then you open parentheses. If you factor out his negative, you factor out his 3, and you factor out one of his x's, all that's left would be a single x. A positive divided by negative is negative. 6 divided by 3 is 2. I factored out his x. I would close it up. Okay, and to check, you would distribute it back in. I'm going to check just by checking with my mind. Negative 3 times 1 is negative 3, and that would be x squared. Perfect. Negative times negative is positive 6x. Good, that works. Okay, so that's the first method. This is the beginning of the chapter. Then we learned to do factor by grouping. This is very similar to the greatest common factor, except we did it 2 times. Group 1 and group 2. Okay, you don't have to underline or color code, but don't put parentheses. Okay, when you factor by grouping or you factor the trinomials for both of these, let's just put a note here. Both of these, the answers look like this: quantity times quantity. Okay, when you take out just a greatest common factor, it's just one set of parentheses. Okay, so I'm not going to write the parentheses till the very end. From the first group, I'm noticing I can take out a 3, and the greatest number of x's is going to be 2x squared. And then that leaves me with x plus 6 divided by 3 is 2. I took both of his x squareds away. That's it. Now, examining just the second 2, this group. If it starts with a negative, take out a negative. The number that's in common is a 2. And they both don't have a letter, so that's it. Open parentheses. I took his negative out, his 2 out. All he has left is x. A negative divided by negative is a positive. And there you go. Okay, I could tell that we're getting it right because we have the same factor. Okay, so how does this work? If they have the common binomial, okay, you put that right here. And sometimes people say that this is the duplicate binomial. The duplicate binomial. Okay, and then these other things right here, 3x squared minus 2, these are what I used to call the leftovers. Okay, and so that is factored. I could check by double distributing or using boxes to see if it makes that polynomial. Okay, and then the last kind of factoring that we learned was factoring trinomials. And the way that a lot of us like to do this was the box method. So we draw 4 squares. The first term goes in the first box, the constant goes in the last box, and then we had to come over here and figure out the multiply and the add number. I multiply the leading coefficient with the constant. 2 times negative 3 is negative 6. Some people like to just multiply those numbers. And then the add number comes from the middle right there, negative 5. And we spend some time figuring these out. How do you multiply and make a negative? Well, one has to be negative, one has to be positive. How do you make a 6? Is it 1 and 6 or 2 and 3? To make negative 5, when you add them, I think negative 6 times 1 would work. Is that true? Do those multiply to make negative 6? Do they add to make negative 5? So we figured them out. It's negative 6x and 1x. Now, when you take them out, let's see. I have to do GCF one time. This one looks pretty easy. What do they have in common? Well, not really anything. I'm going to put a 1 there. And now we'll do kind of just a chain reaction. 1 times x would make 1x. This box up here, if that's x, this has to be 2x. 2x times negative 3 would make negative 6x. Does that work for the last box? Perfect, okay? So my answer are going to be these two binomials right here. One of them is 2x minus 1, and the other one is x minus 3. Okay, so that's a recap of all the ways that we know how to factor. Okay, but sometimes we need to factor an expression completely. Okay, and so what happens is we use more than one method. Okay, so here's the steps. Number 1, always check for a common factor. If they all have something, take it out first. What if this problem right here, okay, what if this problem right here, instead of this was 200x squared minus 500x minus 300. Wow, that problem would have been really difficult to do, except they all have a 100. So what I'll do maybe is factor out a 100. I'll do that first. Okay? If the leading coefficient is negative, you have to divide by a negative. Okay, factor it out. We've been doing that all along. Okay, use grouping if there are 4 terms, and then factoring trinomials if there's 3 or if there's 2. What do you mean if there's 2? Well, if it's something like 4x squared minus 1, that actually is 4x squared plus 0x minus 1 because the middle's canceled out. Okay, then we would use boxes, okay, or your guess and check technique. Okay, all right, number 1. First thing, always, I'm going to bubble this up because this is really important. Check for a common factor. I don't think there's a letter they all have. Can any number be divided? So the only thing that we have here is starting with a negative. Okay, so if the leading coefficient is negative, let's take it out. And then he becomes positive. The positive becomes negative. And that positive becomes negative. Okay? So I took the negative out. But I'm not done. Okay? So starting today, you have to look at your answer and you have to ask yourself, did I factor it completely? Can this trinomial get factored more? Could the answer be negative? And then could this trinomial be factored? That's the question. And what I'm going to do is take this trinomial, I'm going to go off to the side here and use my boxes technique. So I'm going to see if I can get this trinomial factored. Notice the negative, he just kind of stays right there. The negative that you factored out stays in front. The negative stays in front. Okay, let's push this up here. All right, let's go to our boxes. So I'm not going to deal with the negative. I'm just dealing with the trinomial that's left over. Negative, just wait out there for me, please. 2x squared, the constant's negative 3. The multiply number's negative 6. The add number's negative 5. And it looks like, oh, we got this again. Is this the same problem as upstairs that we just did? Is this problem up here? Yes, it totally is. I already did this problem. The answer is 2x minus 1 and x minus 3. So what answer would you put on the answer line? Okay, this is factored a little. This one here is what we called factor completely. Factored completely. Okay, it's been factored as much as I can. The negative's been taken out, okay, and the trinomial got factored into 2 binomials. Okay, let's take a look at some more examples of how we factor completely, okay? This is putting all your skills together. So if you have good skills for everything so far, then this is going to be easier. But some of us are still working at getting better. Step 1, can I take out a GCF? Is there anything they both have in common to make the problem smaller? I notice they both have a 4. I'm going to take that out. And I notice they both have an x, so let's take out 4x. That leaves us with x squared minus 16 divided by 4 is 4. I took out the x, done. Okay, so step 1 was I took out a greatest common factor. Now the question is that done? Or can this quadratic, can it factor more? Okay, so what I'm trying to figure out, does this quadratic factor into two binomials? Okay, and what I'm going to do for that, let's come over here into this space. X squared plus 0x minus 4 is actually the problem. When you make your boxes, we've got x squared, negative 4. So the multiply number is negative 4, and the add number is 0, because he had no middles. So what two numbers, plus and minus, multiply, cancel each other out to make a 0, but multiply to a 4. And the answer is plus minus 2. So negative 2x and positive 2x. Okay, some people look at this and they automatically know it just because they've been practicing so much. I'm going to take out the GCF right there. They both have a negative in common and they both have a 2 in common. Okay, chain reaction, positive 2 times negative 2. If this is negative 2, this must be x, this must be x. It factored. So the two binomials are x plus 2 and x minus 2. This is the answer for the answer line. This has been factored completely. Okay, so have we ever done problems where I asked you to take out a GCF? Absolutely, the beginning of the chapter. Have I ever asked you to factor a binomial like that? Yes, but now I'm asking you to do two steps at once. Okay? All right, remember the first thing we look for, is there a GCF we could take out? Looks like there is. They could all be divided by 2. How many x's can I take out? I can take out an x. Okay. So that leaves me with x squared minus 4 divided by 2 is 2. X squared divided by 1x, he's still got 1x left. Minus sign. 6 divided by 2 is 3. And the x has been factored out. Okay, so step 1, successful. The question is, can this trinomial be factored more? The question is right here. If I put 2x like that, can this trinomial be factored into two binomials? And let's go over here and do our technique to figure out if it can be. Okay, so I've got my boxes. X squared and negative 3 go in the corners. The multiply number is negative 3, and the add number is negative 2. Now, if I'm going too fast here, just stop the video, catch up, work at your own pace. I'm showing the technique, but some of you may need to go faster or slower. To multiply and make a negative, one has to be negative and one has to be positive. I think the numbers are 3 times 1. Those add to negative 2. Perfect. I'll put the negative 3x here and the 1x here. Okay, let's go ahead and factor out the greatest common factor. I like to look at the negative. Since they both have negative, I'll take it out. They both have a 3. Looks good. This box, negative 3 times x. This must be x times x. This must be x times 1. Let's check to make sure that the lasts work. Perfect. So the first binomial is x plus 1, and the second binomial x minus 3. Okay? I'm going to put a little note here. When you write your final answer on the test, okay, don't forget about the GCF. Okay, he's the first thing that comes out. Don't forget to write him. Okay, you can't just write these two. He was part of the problem too. We just took him out first. Okay, all right, one more. Ooh, I'm noticing a polynomial with 4 terms. First thing I'm going to do is take a look to see, is there a GCF? There might be. They're all evens. So I think I'm going to take out, let's see, can I take out a 2? Yes. Can I take out a 4? Oh no, 6 doesn't divide by 4, so 2 it is. Can I take out any x's? No. Okay, so 2 it is. So what's left? 3x cubed plus 6x squared divide by 2, divide by 2. Okay, I think that's it. Now the question is that it or is there more? How do you factor something that has 4 terms? The answer is factor by grouping. Okay, so we've got one group right here, and we've got one group right here. Okay, so the first thing I'm going to do, I'm going to write the 2. Okay, I don't want to forget about that 2. There's a note right here in the little red bubble that says that. I want to see your note when I check your video. All right, from the purple right here. Okay, maybe what I'll do is use like, should I use like big brackets maybe? Maybe use some big brackets just to make sure that all my grouping goes there. I'm going to take out a 3 and x squared. And that leaves me with 1x plus 2. Now, from the green group, is there something they both have? If it starts with a negative, take out a negative. I can take a 2 out of both of them. Okay, so I divided out the negative, the 2. All he's got left is his x. Negative, I divided that out, so this is going to be positive. 4 divided by 2 is 2. Okay, did it work? Yes, it certainly did. If you have duplicates, factor by grouping works. So this is where you write your 2 sets of parentheses. I'm going to put the duplicate right there, the duplicate binomial, and the other one is for the leftovers. The leftovers are the things we took out. 3x squared minus 2. Okay, I gotta say, this is bad. This is not a complete answer. Okay, because don't forget about the GCF. That 2 needs to be out in front. For this right here to multiply and make that answer, it needs to have the 2. I've been showing some people this, and I just want to stop right here and make sure everybody gets a chance to see it. Okay, when you have 4 terms like this, okay, instead of factoring the trinomials with boxes, did you know that you can do the grouping ones with boxes as well? Okay, it's actually really easy. If you have 4 terms, put them into the 4 boxes. We don't even have to do the multiply add numbers because I already have 4 things. I'm going to put 3x cubed in the first box. I'm going to put 6x squared in the second box. I'm going to put negative 2x and then minus 4. So the first and last ones go where I'd expect. The 2 middles I already have. Let's go ahead and take out the greatest common factor. Let's do this. This looks easy. They both have a negative and they both have a 2. Chain reaction. How do you make this box? This is going to need to be an x. How do you make this box? This is going to need to be a positive 2. This box right here is going to need to be a 3. Oh, and x squared. Okay. Does this make the answer here? Is one of the binomials 3x squared minus 2? Yes. And is the other one x plus 2? Some people like to use the boxes because then they do it for all the problems instead of this other technique. Okay, it doesn't matter. I just want you to get the problem right. All right, great job, class.